So if you haven't watched the previous question, please watch that one first. It says, what is the density of 1 mole of carbon dioxide at 2.51 atmospheres of pressure and 455 K? So density equals the mass divided by the volume. Okay, usually it's small m. The mass divided by the volume. And in the previous question, we talked about the gas of the density of a gas at STP is the molar mass divided by the volume of 22.4 liters. But in this case, we have to figure these things out. So it already tells us there's 1 mole, all right? It actually doesn't matter how much there is because density is an intensive property, so it's independent of the amount. But knowing there's 1 mole is useful. So 1 mole has a mass of the molar mass. So this is just 44.1 grams per mole. But what about the volume? Well, this is not at STP. This is not in standard conditions of temperature and pressure. So we need to find the volume. Well, how are we going to do that? We're going to use the ideal gas law. PV equals nRT. In this case, we want the volume to be the variable. So volume equals nRT over P. We're going to assume 1 mole, or it tells us there's 1 mole. R is 0.08206 liter atmospheres per mole K times 455 K, the temperature is already in Kelvin, divided by the pressure, which is 2.51 atmospheres. It's already in atmospheres, that's convenient. So when we do this math, we find that the volume is equal to 14.9 liters. Now we can plug in. The mass is the molar mass because we have 1 molar, we assume 1 mole, which is 44.01 grams, divided by the 14.9 liters. And when we do that math, we find that the density of this particular gas is 2.95 grams per liter. So I should say the density of the gas in these particular conditions is 2.95 grams per liter.